Alright, today we're going to talk about similar triangles and different theorems, postulates to prove that we have similar triangles. Our first similarity postulate is angle-angle, and it states if two angles of one triangle are congruent to the corresponding angles in another triangle, then the two triangles are similar. Looking at the picture over here, I've got angle P is congruent to angle W, angle Q is congruent to angle X. Therefore, by angle-angle similarity, I know that these triangles are similar. Second one here is side-side-side similarity. And it states if three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So I can write my statement, if AB over DE, that ratio is equal to AC over DF, also equal to CB over FE. That states that your sides are proportional, therefore your triangles are similar. We learned in the last section that those ratios prove that those triangles are similar. All right, our next theorem is our side-angle side, and it states if the measures of two sides of a triangle are proportional to the corresponding sides and the included angles are congruent, then the triangles are similar. So I'll write my statement down over here. If AB ratio over DE is equal to CB over FE, and angle B is congruent to angle E, then you can say that your triangles are similar. Okay. Let's do some angles now. Make this bigger for you, maybe. We're going to determine if the two triangles are similar, and if so, tell which similarity shortcut we used. So I'm just going to go ahead and write those. I've got that angle-angle, I've got side-side-side, and I've got side-angle-side. These are all similarities statements here. Okay, so looking at this first one, I see that I have this side right here is 12, and it's going to correspond to this side down here. So I'm going to write my proportion of 12 over 4. I see that I have my right angle here in between for both of them, so that's going to be my included angle. So I know that angle R is congruent to angle W. And so then I'm going to see if 12 over 4 is equal to this 9 over 3. Reducing both of those, I see that 3 is equal to 3, so my ratio is good. So I know that triangle NRQ is similar to triangle TWX. And remember, it's important to write it in that similar order, because that order does matter. Alright, moving over here to the second one, I see I've got that angle included again between the two sides, so I'm going to go ahead and check their ratios. I'm going to say 5 over 11, I'm going to check to see if that's equal to 3 over 7, and that is not, so they are not similar. Okay. Alright, determine the length of x given the two triangles are similar. So using what we know about those ratios and that these triangles are similar, I am going to set up my one ratio of 12 over 4. That's this side here and this side here. And I'm going to set that equal to my hypotenuse over my hypotenuse, so x over 5. To solve this, we're going to use our cross products. 12 times 5 equals to 4 times x. 60 equals 4x. Divide both sides by 4. I have x is equal to 15. All right, moving on to the next one. I know that these triangles are similar because of my two angles here. And so I can set up my proportions to solve. So I'm going to say, oops, I don't want the highlighter anymore. I'm going to go 13 over y equals, and I'm going to have to use this 5 over 15 to go ahead and solve that. So let's see here. I've got 5y equals 13 times 15 here. So that's 13 times 15. Move my page up a little bit. So 5y is equal to 195. Divide both sides by 5. I've got y is equal to, what's that? It's not 195 divided by 5 is equal to 39. All right, so I've got my value of y. Now I'm going to use my value of x. I'm going to use that same proportion of 5 over 15. So I've got 5 over 15 is equal to, and this time I'm going to use 12 over x. 12 over x. Notice I went from small triangle to big triangle, small triangle to big triangle. 5 over 15, 12 over x, so 5x equals 12 times 15. And 12 times 15 is 180. Divide then both sides by 5. I've got x is equal to 36. So x is equal to 36 here, which makes sense because my hypotenuse then is the longest side there. All right. Moving on to our last example here. Sam is landscaping a yard. To see how well a tree shades an area of the yard, he needs to know the tree's height. The tree's shadow, let me draw a shadow here, is 18 feet long. At the same time, Sam's shadow is 4 feet long. So let me draw my tree here. I'll make a green height. Here's my tree height. And then this is Sam's height over here, and I know Sam is 6 feet tall, so I'm going to put 6 here. Go ahead and fill in my triangles just for that. Now we've got our two right triangles, and because we have right triangles, we know that they're going to be similar to each other. Now we're going to set up our proportion. I'll name this side x here. So we're going to try and figure out how tall a tree is. So our proportion is going to be x over 6, and that's going to be equal to 18 over 4. Do our cross products here. So 6 times 18 on one side. So 6 times 18 is equal to 4 times x. 6 times 18 is 108. Equals 4x. Divide both sides by 4 here, and I know that x is divide that by 4, 27. So I know my tree is 27 feet tall. That's the notes then for this last section 9.3. Here's your assignment. You've got the worksheet on the next page. Go ahead and get that started.